In this lesson, we will talk about the ways that you can convert between rectangular and polar coordinates. This will demonstrate the methods that you can use when taking singular points in either polar or rectangular form and convert to the other, or take entire equations that are in either polar or rectangular form and convert to the other. The equations that we're going to be using here are all equations that have been established in the past. Let's recall these. To think about them, what I would recommend to reference or think about is a point in a polar coordinate system. I'll, for convenience, put this point in what I would consider to be quadrant 1. This point, r comma theta, means it has theta as its rotation and r as its distance. If I overlay that on an x and a y plane, well, that would mean x is the distance along the x-axis up to a point, then y is the distance up the y-axis or up vertically. Meaning we really have a right triangle here with two legs of x and y, a hypotenuse of r, and an inscribed angle measure of theta. If we use various concepts from the past to relate these things, we can come up with some of our equations. For example, I could use some of the trig functions such as sine and cosine. If I use sine of theta would be the opposite over the hypotenuse, so y over r. And cosine of theta would be the adjacent over the hypotenuse, so x over r. Since r and theta are polar coordinates, I can put those together by multiplying those equations by r, and I can come up with our first set of equations used for conversion, which here is x equals r cosine of theta, as well as y equals r times sine of theta. These equations in particular are very useful if you are given a singular point in polar coordinates, r and theta, and you want to find what they are as a rectangular coordinate, x and y. Because here we can plug in an r and a theta, and we can find values for both x as well as y. These equations are also going to be useful for situations where I have an equation in rectangular form involving x and y, and I want to get it to polar form or to polar coordinates. I can replace all instances of x and y in an equation with these two equations we have just established. Replace all instances of x with r cosine of theta, and replace all instances of y with r sine of theta. So these have multiple uses, but they're not the only equations, because I could also relate some of these side lengths. Since this is a right triangle, I should be able to use the Pythagorean theorem. The Pythagorean theorem is where we get our next equation. The Pythagorean theorem would take the hypotenuse squared, which is here r squared, and that would equal the sum of the two side lengths, each squared. We get r squared equals x squared plus y squared. We can also look at one other trig function, which would be tangent. If I look at tangent of theta, which is the opposite over the adjacent, that would be y over x, which is our fourth equation that we can use for conversion purposes. These last two equations can be used for if you have a rectangular coordinate in x and y, and you want to find what values of r and theta you would have. If I have x and y, I can plug those into this Pythagorean theorem in order to solve for r. And if I have x and y, I can plug that into the quotient formula for tangent to solve for theta. We can also use these equations, as well as the previous two, when taking polar equations and converting them into rectangular ones. If I can manipulate my equation so I see r squared terms or terms of tangent of theta, or maybe r times sine of theta or r times cosine of theta, then I can use any of these equations to change polar functions or equations into rectangular ones. Overall, the typical strategy when trying to convert an equation from rectangular to polar is to replace every occurrence of x with r times cosine of theta and every occurrence of y with r times sine of theta, and to use identities to simplify as necessary. When converting equations from polar to rectangular, however, that isn't as straightforward, and in most circumstances, we attempt to rearrange the given polar equation to do something to both sides of the equation, so that the four conversions here can present themselves. By that we mean take your equation that's in polar coordinates and apply various operations to both sides in order to see r times cosine or r times sine or r squared to show up, and therefore we can then use those to simplify and replace with rectangular coordinates.